So I've got the joystick integrated into the motor controller now. I got this joystick off of eBay a while back, and I opened it up and I added a couple of accelerometers. You can see them on this drawing here. There's two accelerometers in there for redundancy. So I can use this joystick, tilting it back and forth, to simulate the half G forces that the aircraft will see as it goes around a corner. And then I'll use that to control the motor. Then I also found this pretty awesome plotting function. It takes data off the UART and plots it in real time. So as I move the joystick back and forth, you can see the acceleration, left and right change. Then I also put a couple of motors, the kind of motors that are used in your phone to make it vibrate, to inject some noise into the signal to simulate the motor vibration, which is something I'll have to filter out. So you hit this button here and you can see the difference that it makes. So I'll be able to use that as a simulated noise source to work on the filter that I'll need to filter the motor vibration out. I've also got this linear potentiometer here, which is all wired up and integrated in. So the idea is, once this is all together on the test stand, I'll be able to input and acceleration with this. Then I'll calculate the angle that the wheels need to rotate to, and turn on the motor, and then this potentiometer will measure the stroke of the linkage that slants the wheels, and when it gets the right point, it'll stop. So also have manual control of the motors, and you can see on the screen over here when I turn them on that blue signal is actually the rotating magnetic field being fed to the motor. As it goes from low to high, that's one rotation of 360 degrees of the magnetic field. So, coming along.